Welcome to our channel Be Always Learner. Today we are going to solve the numerical based on the forced response, and that is also called zero state response. अगर आपको वीडियो पसंद आए तो आप लाइक करिएगा और शेयर करिएगा और सब्सक्राइब भी करिएगा। तो दिस इज द न्यूमेरिकल जो हम आज कंसीडर करेंगे, दैट इज yn minus 1.5 yn minus 1 plus 0.5 yn minus 2 is equal to xn। और इनिशियल कंडीशंस इस केस में डिफाइन नहीं होंगी बिकॉज हमें फोर्स्ड रिस्पॉन्स निकालना है। इनपुट हमें चाहिए तो xn is equal to 2 raised to the power n, un is input given to us। now अब हमें निकालना है y forced response। So forced response is the combination of homogeneous response. The forced response will be the combination of homogeneous response and the particular solution. The forced solution will be equal to the homogeneous solution plus particular solution. So सबसे पहले हमें इसमें homogeneous solution find out करना है, और homogeneous solution find out करने के लिए the xn HS find out करने के लिए the first condition is xn will be equal to 0. So for that we have to calculate yn, that is 1.5 yn minus 1 plus 0.5 yn minus 2. So that is equal to 0. If it is equal to 0, the generalized homogeneous solution will be hn is equal to lambda n. Now we can put the value y into the above equation, So put in equation 1. So this is equation 1. So for that हम इसको put करेंगे तो हमारे पास resultant जो polynomial आएगा, that will be lambda raised to the power n minus 1.5 lambda n minus 1 plus 0.5 lambda n minus 2 is equal to 0. We can take lambda n minus 2 common and we are left with the term in the bracket lambda square 1.5 lambda plus 0.5 bracket close, that is equal to 0. So this is not equal to 0, this is equal to 0. So we can put this term in the bracket term, that is equal to 0. We have to calculate the roots. So the roots are lambda 1 will be equal to 1 and lambda 2 is equal to 0.5. So these are the roots which are available with us. Now we are talking about the homogeneous solution. The homogeneous solution हमारे पास available होगा, that is yHn। तो उसका जो जनरल फॉर्म था that is c1 into 1 raised to the power n plus c2 0.5 in the bracket raised to the power n। ये इसका homogeneous solution available था। Now we can make it separate. Now for another case we have to find out the particular solution. So for that we should have the input, that is xn 2 raised to the power n un। अगर ये इनपुट है तो जो हमारे पास टेबल अवेलेबल थी, इस टेबल के बेसिस पे हम कैलकुलेट कर सकते हैं कि पर्टिकुलर सॉल्यूशन क्या होगा। ठीक है, if this is the input. So for that we can write, if xn is the input, the solution will be yp, that is equal to yp function of n, that is equal to k 2 raised to the power n un। ये इसका solution होगा। Now we are having xn and we are having yp. We are having the difference equation also, हम इसमें values को put करेंगे अब। So we are having y in this form, so we can put it like k 2n un minus 1.5 k 2 n minus 1 u n minus 1 plus 0.5 k 2 n minus 2 u n minus 2 is equal to 2 raised to the power n u n. सो पुट करने के बाद हमारे पास ये इक्वेशन आती है और हमें इसका सॉल्यूशन निकालना है फॉर फाइंडिंग द वैल्यू ऑफ k. सो टू फाइंड द वैल्यू ऑफ k we are going to put the n is equal to 2 or such a value of n where no term vanish. No term vanish. So at n is equal to 2, no terms are vanish. So for that we can calculate k into 2 raised to the power 2 minus 1.5 k 2 raised to power 1 and plus 0.5 k is equal to 2 raised to the power 2. So to normalize it or make it multiply an algebraic solution, and we have to find out the value of k. So to add and subtract, after add and subtract, we are having 1.5 k is equal to 4, and that value of k leads towards 8.8 by 3. So for that we are having this particular solution here, this particular solution yp, that yp n is equal to, put the value of k here, that is 8 by 3 into 2 raised to the power n un. ये हमारे पास पर्टिकुलर सॉल्यूशन ऑब्टेन कर लिया हमने. तो हमारे पास फोर्थ सॉल्यूशन जो हम देख रहे थे वो था सम ऑफ होमोजेनियस सॉल्यूशन, sum of homogeneous solution and some particular solution. So this will be C1 1 raised to the power n plus C2 0.5 raised to the power n and plus particular solution 8 by 3 2 raised to the power n un. So ये हमारे पास एक फोर्थ सॉल्यूशन ऑब्टेन हो गया हमें. अब इस फोर्थ सॉल्यूशन में वी हैव टू फाइंड आउट द वैल्यूज ऑफ कोएफिशिएंट्स. सो टू फाइंड आउट द वैल्यूज ऑफ कोएफिशिएंट वी हैव टू हैव द वैल्यू ऑफ फोर्थ सॉल्यूशन एट n is equal to 0. At y0 from this we can write y0 is equal to c1 plus c2 plus 8 by 3. In the same way, at n is equal to 1, y1 will be equal to c1 plus 0.5 c2 plus 16 by 3. So these are the two equations we are having, right? So we can write it equation number 2 and equation number 3. Now from these are the two equations we are having here. Now the difference equation, this is the difference equation we are having, the initial equation. So that is, by putting n is equal to 0 we are having y0 minus 1.5 y minus 1 plus 0.5 y minus 2 that is equal to x0. So because हम फोर्स रिस्पॉन्स निकाल रहे हैं तो हमारे पास जो इनिशियल कंडीशंस हैं वो 0 हैं. सो दीज टू वैल्यूज आर रिप्रेजेंटिंग द इनिशियल कंडीशन, तो ये 0 है हमारे पास. सो दिस इज 0 and this is 0. Now we are leading with the term y0 that is equal to x0. Now we have to calculate the value of x0. The value of xn is given by xn is given by 2 raised to the power n un. So x0 के ऊपर क्या वैल्यू होगी इसकी, 2 raised to the power 0 u0, that is 1. So this is 1. Now similarly we have to calculate the value for y1. So we are able to calculate the value for y0. Now we have to calculate the value for y1. So y1 निकालने के लिए हमें क्या करना पड़ेगा, डिफरेंस इक्वेशन जो गिवन इक्वेशन है उसमें n इज इक्वल टू 1 पुट करना है. तो उसके लिए y1 माइनस just see this equation and put the value y1 minus 1.5 y0 and plus 0.5 y minus 1, that is equal to x1. Now again we have to calculate the value of x1. So here we can calculate the value of x1. This will be 2 raised to the power 1 use u1. So this is comes out to be 2. So we can calculate, because this is representing the initial value, so this value is 0. y0 is 1. So we can write y1 minus 1.5 is equal to x1. x1 is 2. So from this we can implies that y1 जो हमारे पास आएगा that is 3.5. Fine. So we can write here that we are having value of y1 and value of this is the value of, we have to use a different color, this is the value of y1, this is the value for y0. So both values we are having. So for that we can write y0 is 1. So 1 is equal to c1 plus c2 plus 8 by 3. So from this we can write, and from this what we can write, so we can write y1, the y1 is 3.5 is equal to c1 plus 0.5 c2 plus 16 by 3. So from these two equations we can derive these two equations. Now from this we can simplify it. c1 plus c2 is equal to minus 5 by 3, and this, from this equation we can write c1 plus 0.5 c2 is equal to minus 11 by 6. So these are the two equations, two variables are there, so we can solve it, and after solving we can write the value of c1 is equal to minus 2 and value of c2 is 1 by 3. Now what we want to find out, the force response. The force response is denoted by yf, and here it is represented. Now from this we can write here that is minus 2, the c1 is minus 2, and multiplied by 1 raised to the power n plus, what is the value of c2, that is 1 by 3.5 raised to the power n plus 8 by 3 2 raised to the power n un. Fine. So we can represent it minus 2 un plus 1 by 3. For causal system we are writing 0.5 raised to the power n un plus 8 by 3 to n un, because yf is defined for n is greater than 0, so that's why we can write it like this. Hope you understand the numerical, and please share the video and subscribe the channel, and do not forget to press the bell icon.